In the sweltering, restless days of July in the year 2015, a small but tenacious spacecraft named New Horizons raced through the black expanse of space and swept past the distant world of Pluto, a planetary body that, until that very moment, had existed mostly in the shadowy realms of speculation, myth, and imaginations. As New Horizons streaked by at nearly 11 miles per second, it accomplished something truly extraordinary. It shattered decades of assumptions and revealed Pluto not as a cold, forgotten outpost, but as a vibrant, dynamic realm on the edge of our solar system. Now, a decade later, scientists are still sorting through the avalanche of data and grappling with the implications of what they found. What did New Horizons truly uncover? And why do so many experts believe that Pluto could transform our entire understanding of planetary science, the birth of worlds, and even the potential for life beyond Earth? To appreciate the full magnitude of the New Horizons mission, we need to rewind almost a century. The story begins in the year 1930, when a young astronomer named Clyde Tombaugh gazed through the telescopes at Lowell Observatory in Arizona and discovered what he believed was our solar system's ninth planet. Pluto quickly captured the world's imagination. For over 70 years, it was celebrated as the lonely guardian of the outer solar system, a mysterious world orbiting in the deep, frigid twilight, far from the sun's warmth and the reach of human technology. Schoolchildren memorized its name, and generations of scientists dreamed of exploring its icy surface. But in the year 2006, Pluto's fate took a dramatic turn. The International Astronomical Union, after long and heated debate, officially reclassified Pluto as a dwarf planet. This decision, based on new and controversial criteria about what constitutes a full-fledged planet, sparked a firestorm of arguments. Around the world, students, teachers, and even professional astronomers debated in classrooms, lecture halls, and coffee shops. Some mourned the loss, feeling as though a cherished member of the planetary family had been banished. Others embraced the new scientific clarity, arguing that categories must evolve as knowledge progresses. But amid all the controversy, something remarkable happened. Pluto did not fade from public consciousness. Instead, it became more fascinating than ever before. A cosmic underdog, the subject of new questions and renewed curiosity. This curiosity set the stage for one of NASA's boldest and most ambitious ventures. On a frigid January morning in the year 2006, the New Horizons spacecraft launched from Cape Canaveral, embarking on an unprecedented journey of explorations. Its mission, to travel almost 3 billion miles, an almost unfathomable distance, equal to circling the Earth more than 32,000 times, to reach Pluto and unlock its secrets. The journey would take nearly a decade, demanding patience, precision, and unwavering commitment from the mission team. Imagine the enormity of the challenge. Navigating through the cold, silent darkness of space, New Horizons had to thread a needle. A tiny window in space, just 36 by 57 miles wide. To put that in perspective, it is as if a commercial airliner flew from New York to Sydney and landed with an accuracy no greater than the width of a tennis ball. The margin for error was vanishingly small. New Horizons had a single opportunity to glimpse Pluto up close, the very first in the history of humanity. The stakes could not have been higher. Success would open a new chapter in planetary science, while failure would mean decades of lost opportunity. So what did New Horizons find as it approached this enigmatic world? The first images sent back to Earth stunned scientists and the public alike. Instead of a featureless ball of frozen rock, Pluto revealed itself as a world of dazzling complexity. There, etched into its surface, was a vast, bright, heart-shaped region, quickly nicknamed the Heart, and later formally named Tombaugh Regio, in honor of Pluto's discoverer. This icy heart, composed primarily of nitrogen ice, stretches over 1,000 kilometers across, making it the largest known glacier in the entire solar system. Its smooth, unblemished surface suggests it is geologically young and constantly being renewed. Elsewhere, New Horizons spotted mountain ranges of solid water ice, with some peaks towering as high as 11,000 feet above the surface, comparable to the heights of the Rocky Mountains on Earth. These mountains, believed to be less than 100 million years old, are remarkably young when compared to the solar system's age of more than 4.5 billion years. Geologists like Jeff Moore, a member of the New Horizons imaging team, were awestruck, declaring, "This is one of the youngest surfaces we have ever seen in the solar system." But the surprises did not end there. The spacecraft's instruments detected a thin, blue haze encircling Pluto's atmosphere rich in nitrogen, with layers of complex hydrocarbons that scatter sunlight in a way that produces a sky as blue as Earth's. This was completely unexpected. And, perhaps even more astonishing, New Horizons found strong evidence of ongoing geological activity. There are ice volcanoes, cryovolcanoes, that may still be erupting today, reshaping the landscape with flows of water ice and other exotic ices. Pluto's surface is not a static wasteland, but a dynamic, evolving world. Perhaps the most tantalizing discovery was the possibility of a subsurface ocean, a hidden layer of liquid water beneath Pluto's icy crust, kept warm by the slow decay of radioactive elements in the core. If confirmed, this would place Pluto in an exclusive club of worlds with hidden oceans, alongside Jupiter's moon Europa and Saturn's moon Enceladus. Such oceans are considered prime candidates in the search for extraterrestrial life. Could simple organisms exist in the darkness beneath Pluto's frozen shell? This question is now the focus of intense scientific investigation. New Horizons also turned its cameras and instruments on Pluto's moons. Charon, the largest of Pluto's 5 known satellites, revealed its own set of mysteries. Its surface is marred by a colossal tectonic belt, an enormous scar that stretches across its equator, hinting at a violent and active past. Scientists believe Charon may once have harbored its own internal ocean, which froze and expanded, cracking the surface apart. Even more curious is Charon's North Pole, which is capped by a vast, dark red region. This is unlike anything else seen in the solar system, and researchers now think it formed from gases escaping Pluto's atmosphere, traveling through space, and settling on Charon's surface over millions of years, a process unique to this distant system. The other moons, Nix, Hydra, Styx, and Kerberos, though tiny, also surprise scientists. Their surfaces are unexpectedly bright, suggesting they are covered in fresh ice, perhaps the result of past collisions or ongoing resurfacing. All of Pluto's moons that can be age-dated by counting impact craters appear to be the same ancient age. This points to a dramatic origin, a giant collision long ago that created the entire Pluto system, reminiscent of the massive impact that formed our own moon. Recent theories, such as the kiss and capture idea, suggest that Pluto and Charon may have once been separate worlds that gently merged after a slow gravitational dance, a possibility that adds another layer of complexity to their story. Yet for every mystery New Horizons solved, new questions arose. How can Pluto, a world so small and so far from the Sun, remain geologically active when many larger worlds have become cold and lifeless? What fuels its internal heat? And how do its glaciers and volcanoes defy expectations? Why does Pluto's thin atmosphere escape into space at a much slower rate than scientists predicted? And on a more philosophical level, what does it truly mean to be a planet? And does Pluto's story force us to rethink our definitions? Let's take a closer look at the planetary debate that has raged for decades. The controversial decision in 2006 to demote Pluto was based on 3 criteria. A planet must orbit the Sun, be massive enough for its own gravity to shape it into a sphere, and must have cleared the neighborhood around its orbit of other debris. Pluto fails the last test, as it shares its path with many other icy bodies in the Kuiper Belt, a vast ring of frozen fragments and debris that stretches far beyond Neptune. This region, sometimes called the third zone of the solar system, is home to countless dwarf planets and mysterious objects. But this official definition has not silenced the debate. Many planetary scientists argue that the criteria are arbitrary and do not reflect the true diversity of worlds we observe, both in our solar system and in planetary systems around other stars. Kirby Runyon, a planetary scientist at Johns Hopkins University, calls the reasoning behind Pluto's reclassification fallacious. Philip Metzger, a physicist at the University of Central Florida, has shown that the controversial planet-clearing rule is almost never used in scientific research. Instead, Metzger and others advocate for a broader definition, one that would recognize Pluto, the Moon, and even large asteroids as planets of various types. This more inclusive perspective would shift our focus from rigid categories to the rich diversity of planetary bodies. Why does this matter? The way we classify worlds shapes the questions we ask and the missions we plan. If Pluto is considered a planet, then the outer solar system is far richer than we ever imagined. A region filled with diverse, active worlds, not just barren rocks. As Jeff Moore put it, Pluto is not just another icy object, it is a world. and worlds matter. The implications reach beyond Pluto itself, challenging us to reconsider how we explore and understand the universe. As New Horizons left Pluto behind, it continued its journey into the unexplored territory of the Kuiper Belt, a region so mysterious that it is often described as the solar system's final frontier. Here, New Horizons made history once again. In early 2019, it performed a flyby of a distant object known as Arrokoth, previously nicknamed Ultima Thule. This contact binary, composed of two icy lobes gently joined together, offered an unprecedented window into the earliest moments of solar system formation. The pristine nature of Arrokoth, largely unchanged for over 4 billion years, allowed scientists to study the building blocks from which planets like Earth were born. Then, in the year 2024, New Horizons contributed to the discovery of a second Kuiper Belt, expanding our knowledge of the solar system's outer reaches even further. These findings suggest that the architecture of our solar system is far more complex and layered than previously thought, with vast populations of icy worlds lurking in the darkness. The mission's achievements have not stopped at planetary science. In June of the year 2025, New Horizons became the first spacecraft to perform interstellar navigation, using the positions of distant stars, such as Proxima Centauri and Wolf 359, to calculate its own position with an accuracy of about 4 million miles. These deep space navigation feats are more than just technical triumphs. They pave the way for future missions that may one day venture into interstellar space, reaching out beyond the sun's influence into the realm of other stars. The technology and methods tested by New Horizons could be the foundation for humanity's first true voyages to the stars. Looking back, what is truly remarkable is how New Horizons transformed our understanding not just of Pluto, but of the solar system itself. 10 years ago, Pluto was thought to be a frozen relic, geologically dead and atmospherically inert. Today, we see it as an active, complex world, a place of ice volcanoes, blue skies, shifting glaciers, and perhaps even hidden oceans. As Hal Weaver, project scientist at Johns Hopkins University, reflected, "It is strange to think that only a year ago, we still had no real idea what the Pluto system was like. But it didn't take long for us to realize Pluto was something special, and like nothing we ever could have expected." But if New Horizons was a revolution, it may only be the beginning of Pluto's new story. Scientists are already dreaming of the next wave of exploration. The most ambitious proposal so far is the Persephone mission, a planned 50-year orbital study of Pluto and its largest moon, Charon. If Persephone is approved and launched, it could reach Pluto decades from now, settling into orbit and spending half a century unraveling its mysteries. The mission aims to build on the legacy of New Horizons, with advanced instruments that could reveal secrets hidden beneath Pluto's surface and provide a continuous, close-up view of its changing landscape. What questions could Persephone answer? First and foremost, does Pluto truly harbor a subsurface ocean, locked beneath its shell for billions of years? If so, what keeps it liquid? And could it support life? Persephone could also study Pluto's thin, blue atmosphere, observing how it expands and contracts as Pluto travels along its long, elliptical orbit. Over time, scientists could watch the seasonal changes that play out over decades. The orbiter could map the surface in exquisite detail, track the slow flow of glaciers, and even search for signs of active cryovolcanism, volcanoes that erupt not molten rock, but cold, slushy ice. By monitoring these processes over years, Persephone would provide insights into the forces that shape icy worlds throughout the cosmos. Charon, too, would be a prime target. Persephone could investigate its dark red polar cap, study its tectonic scars, and search for evidence of past or present oceans. The orbiter's suite of instruments could analyze the chemical composition of the surface, hunt for organic molecules, and measure the lingering heat from within. And beyond Pluto and Charon, the orbiter could examine the other moons, searching for clues about their formation, internal structures, and evolution. Yet, the challenges of such a mission are immense. Pluto lies more than 3 billion miles from Earth, so far that radio signals take more than 4 hours to cross the Gulf. Every mission is a high-stakes gamble, where a single failure could mean decades of lost opportunity. Funding for such a long-lived project is always uncertain, and the technology required to survive and operate in the frigid, dim environment of the Kuiper Belt is daunting. Persephone would need to function autonomously for decades, relying on nuclear power and advanced artificial intelligence to carry out its mission. The orbiter would be exposed to harsh radiation, micrometeoroid impacts, and extreme cold, all challenges that require innovative engineering solutions. Despite these hurdles, the scientific payoff is irresistible. Unlocking Pluto's secrets could help us understand the entire class of dwarf planets and icy worlds that lurk beyond Neptune. It could shed light on the origins of the solar system, the processes that shape planetary evolution, and the conditions that might allow life to arise in the most unlikely places. As we discover more about Pluto, we also learn more about ourselves, our place in the cosmos, and our relentless drive to explore. The data collected could inform the search for life on other icy worlds and shape our understanding of planetary systems orbiting distant stars. The debate over Pluto's planetary status is not just academic. It reflects deeper questions about how science progresses, how we define categories, and how we adapt to new knowledge. The story of Pluto is a lesson in humility. 10 years ago, most scientists believed they had Pluto figured out, a frozen, dead rock orbiting in the darkness. New Horizons proved them wrong. This should remind us to stay curious, to challenge our assumptions, and to remain open to surprise. Science thrives on unexpected discoveries, and Pluto's story is a perfect example of why we must never close the door on possibility. In a practical sense, Pluto's story is also an inspiration for technological innovation. New Horizons was a triumph of engineering, navigating across nearly 3 billion miles, with a precision so fine it has been compared to landing a coin on top of another coin from thousands of miles away. Its deep space navigation experiments, imaging stars like Proxima Centauri and Wolf 359, have set the stage for future missions to even more distant worlds. These achievements remind us that the boundaries of exploration are always moving outward, driven by ingenuity and determination. The technologies developed for New Horizons are already influencing the design of next-generation spacecraft, including autonomous probes and potential interstellar precursors. Perhaps most of all, Pluto's journey is about perseverance and the power of teamwork. The New Horizons mission was the product of decades of planning and thousands of people, engineers, scientists, technicians, and dreamers, working together for a goal that many thought was impossible. Their success is a testament to what humanity can achieve when we pursue knowledge for its own sake, driven by curiosity and wonder. The mission's international collaboration, drawing on expertise from across the globe, is a powerful reminder that some goals can only be reached when we work together, crossing borders and disciplines. So what does the future hold for Pluto, and for our understanding of the solar system's frontier? The answers will come only with time, new missions, and the willingness to keep exploring. Will Pluto regain its status as a full-fledged planet? The debate is far from settled, and new discoveries could tip the scales. If scientists confirm an active subsurface ocean or ongoing geological processes, the case for Pluto's planetary status may become irresistible. Alternatively, we may find that the very idea of a planet must continue to evolve as we learn more about the cosmos. But perhaps the real lesson is that the universe always has more to show us. As Hal Weaver observed, it is strange to think that only a year ago, we still had no real idea of what the Pluto system was like. Each discovery opens the door to new questions, and each mission reveals another layer of complexity. The solar system is not a static set of objects, but a living, changing environment full of surprises. Today, New Horizons is still out there, hurtling through the Kuiper Belt, far beyond the known planets, still sending back data, still expanding the boundaries of human knowledge. Its mission has been extended through at least the year 2029, with the possibility of new flybys of even more distant Kuiper Belt objects in the years to come. With every passing year, the spacecraft covers millions of miles, pushing ever deeper into the unknown, and providing scientists with precious data about the outer reaches of our solar system. Meanwhile, on Earth, the debate continues. Should Pluto be a planet again? Should we recognize the diversity of worlds in our solar system? Or stick to strict definitions? What new missions should we send? And what risks are worth taking? These are the questions that keep planetary scientists up at night and capture the imagination of people around the world. The answers may shape not only how we see Pluto, but how we approach the exploration of other worlds, both within and beyond our solar system. If you found Pluto's journey as awe-inspiring as we did, hit that like button and subscribe for more stories from the edge of science and technology. What do you think? Should Pluto be a planet again? Share your thoughts in the comments below. And remember, The universe is full of surprises, just waiting for someone curious enough to go and find them. Our journey of exploration is only beginning, and the next